Hello everyone and welcome to my YouTube channel. In today's video we are going to take a look at how we can combine segment anything model with the Stable Diffusion model to create something really cool. So I'm not going into details of how segment anything model works. I think a lot of people have already done that, and you can also read the paper if you want to, but this is a really cool model. The best part is it's open source, and the model weights are available, and data is also available to the user, so you can build really a lot of cool things using this. And it seems like the model is quite good, so let's give it a try and see how we can combine it with segment anything model with the Stable Diffusion model. And for today's video we are going to be using the GitHub repository for segment anything model, so you must take a look there. And here is the GitHub repository. So here you can see instructions on how to install it. So that's what I did. I installed it this way. I already had all these dependencies installed, so you can, if you don't have it, just install it. And then I downloaded the weights VIT SAM model. So I'm going to be using this library, and then I'm going to be using Stable Diffusion from Hugging Face Diffusers, and I'll be using Gradio to build the UI. So let's get started. So as you can see, I have created a workspace, and I have already downloaded the weights. So I'll be using VITH, it's the largest one. And I did this a couple of hours ago and I really liked it, so I thought I will share it with you. So I do have a reference using which I will be writing some code, but it's quite easy to do it yourself too. So let's start by creating a file called app.py, and we will import some of the stuff that we would need. So let's import Gradio. So we have our imports in place, and these are the libraries that we will be using today. So I can just write here SAM checkpoint. So this is the path to the weights. So it's in my weights directory, and I think I can just copy the name from here. Copy path, or I can just copy the relative path. Okay, so I have the weights here. Now I have to define the model type, and this comes directly from the example in the Git repo of SAM. So VIT_h. Here I can also define the device that I will be using, which is CUDA, and then I have the SAM model itself. So to use that, you have to call SAM model registry, then the type of the model, model type, and then you have to define the checkpoint. So checkpoint is SAM checkpoint. So now you have the SAM model, and then we send model to device, just like we do for any PyTorch model. The second model that we need, and yeah, we have to initiate the predictor class, which is SAM predictor. And here you have the model. Okay, and the next thing that we need today is the Stable Diffusion Inpainting pipeline. So I can just say pipe go to Stable Diffusion Inpainting pipeline from pre-trained, and here I have the model name. So from Stability AI and Stable Diffusion 2 Inpainting. Okay, and I can have the torch D type, so I can use float 16, save some memory. Okay, so we got the pipeline for Stable Diffusion, and we can also send it to CUDA. Okay, so we got the basic components up and running. If you don't have downloaded this model before, Hugging Face Hub is going to download it for you. And now what we are going to build, we are going to build a simple demo in which we input an image, we select some parts of the image, and then we can replace that part with given some prompt. We can also replace the background instead of the object. So we initialize a Gradio block with gr.blocks as demo, and then we have a bunch of row. So let's say we have with gr.row, here we have what did I have, input image, which is, we can say gr.image, and then there is some label. Input, we have the mask image, and the same thing. I should use GitHub Copilot for this. So this will be called mask, and output image, and this will be the same again, and it will be called output. So I got one row in which I have these three image components, and then I get another row, and here I can have prompt text. So what kind of prompt I want to use, this is gr.textbox lines equal to 1, just single line. You can do multiple lines if you want, and label equal to prompt. So I'm just going to use the positive prompt, or the prompt, not the negative prompt, but you can have as many prompts as you want. So now we add one more row with gr.row, and this row will have a submit button. Submit equal to submit. Okay, so we got all these three text fields, these three image fields, text box, a submit button. Okay, so how the SAM predictor works is you have to supply it with a bunch of pixel values, the coordinate values for an image, X and Y coordinates, and one label. So if you supply, like, if I click on a point in an image and it generates a mask for me, and if I think it's not good enough, then I can give it more points with the same label. So that's what I'm going to be doing today. But before that, I will write a simple function inside this called inpaint. So the inpaint function will take an image, it will take a mask and a prompt. And we are using Stable Diffusion 2.1. I'm going to convert the image to a PIL image, image.fromArray. So these are numpy arrays, and here I can write image, and I can do the same thing with the mask image. So shouldn't have done that. Okay, mask and mask image. So I got the two mask images, one image and one mask. And now we need to resize it to 512 cross 512. So image equal to image dot resize 512 comma 512, and mask equal to mask dot resize 512 comma 512. And my output will be the pipeline. So here also I'm using the default parameters. So prompt is prompt, image is image, and mask image is mask. So I'm not doing anything interesting here. I'm just using it from the example. And here I can say dot images, so I get to get all the images, and I only need the first one. Very simple. And here I can return output. So now I had a few buttons here. I had the submit button. So how I want to build this is, if someone clicks on the input image, anywhere on the input image, a mask should be created, and then the mask should be used for inpainting. So Gradio it's about to include a feature. It's still in pull request, so I installed Gradio from source, but now you can click on an image to get the pixel coordinates. So here I can write input underscore image dot select. So this will be a select event, and I will use a function called generate mask, and this function will take the input image as the input and provide output in mask ing. So this generate mask is something that we have not written yet, so we can just write the function here. It will take input image and an event, so just call it EVT, which is Gradio select data type. Okay, so now we have the mask, and here we can just write what I'm going to do is, the selected pixels are going to be stored in EVT. So I'm not coding in a very great way today, but this works. Selected pixels, I make it a list, and here I can say selected pixels dot append evt dot index. So this will store the current selected pixel. And once you have the selected pixel, we can say for the SAM predictor, set the image as image, which is the original image input by the user, and then create an input point or points. So let's just call it input points, which is an array of coordinates, xy coordinates, and p.array selected pixels. And input label is, we will say like everything is foreground. There are only two labels. So np.ones input points dot shape 0. So as many points as you have, as many labels you have. And then we can just say, okay, the mask is, we can just call the predictor dot predict. So this is SAM, and inside that we have point coordinates. Point coordinates is input points, point labels is input label, input labels. And you can have multiple masks as output, but I'm going to simplify it. I just need one mask. And it will return a mask in the shape of 1, size, size. Okay. And if you have multiple masks, you'll have multiple here. Okay, so now I have to convert the mask to a PIL image. So image dot from array mask, and here I will use the first one. Okay, so the mask has now been converted into PIL image, and now I can return the mask. Okay, so what's happening is whenever someone clicks on the input image, it sends the point to selected pixels, and using selected pixels we construct input points and input labels, and which are then used along with the image to create a mask from SAM. And mask is displaced in mask image. So now we also need the inpainting thing. So I can just do submit dot click, and here I have inpaint, the inpaint function, which has inputs, input image, mask image, and prompt text, and the output is output image. Okay, so far so good. And now to launch the demo, if name, you can just launch the Gradio demo using demo.launch. Okay, so a quick walkthrough. We have the input image, mask image, output image, and prompt text and submit button. Whenever someone clicks on any point at input image, it gets recorded in selected pixels, which in turn creates an input points array. Inputs labels is the same, all are ones, and then we use SAM predictor to predict a mask using the image and the input points, and that mask is returned. The mask in turn is being used for inpainting using Stable Diffusion and the Hugging Face Diffusers library. So let's try to see if it works. I'll just forward this port, and here I can say Python app.py or Gradio app.py. So it will take a few seconds to start, and then we can go to the Firefox and see if we have something there. So I got an error saying Gradio has no attribute block. Obviously it should be blocks, but here we are not using blocks, we will be using row. So yeah, good that we got this error. And okay, let's launch it using Gradio. If you launch it using the Gradio command, whenever you refresh it, whenever you make changes in the code, this will restart automatically. Okay, so for me all the files were already downloaded, so let's go and see if we are getting something in the web browser. So the app is working, and what we can do is let me upload an image. So image of a girl, and if I click somewhere, I hope you can see the cursor. If not, I'm clicking on somewhere on the jacket, and it should generate the mask. So it generated the mask, and if I want to enhance it, I can keep clicking on the jacket more. So if it doesn't find some part on the right side, I will click there, and the mask will change. Now I can write the prompt: girl wearing a red jacket, and click on submit. And now, using this mask that has been created by SAM model and Stable Diffusion Inpainting model, we have a new and different image. So yeah, it's pretty cool. So like, if I want to select more, I can. So now I have selected like everything by clicking at different points. And let's see if I can change this and if it still works. Okay, so yeah, something bad happened, because see, now I have for some reason selected the face, and I shouldn't have selected that. But that's okay. But you get the idea. And now I want to show you something else that you can do with it. So let's go back to our VS Code, and here what we can change is we can say like the image is the background. So I can just say here mask is a binary array, so I can say np dot logical not mask. Okay, so now it will select everything in the foreground, and the background will change, which is also I think it's quite cool. So let's see how that works. So I think this has loaded again, and here is my app. Let me add the same picture, and now I will click on the image, and you see the foreground is black. Previously the background was black. So now I've selected the girl in the picture, the object, and a girl on a beach. Let's submit and see what happens. So yeah, pretty cool, right? And you can keep clicking on submit, and it will give you different results each time, and you can choose the one you want. So now you can take your own picture and keep changing the background. So yeah, that's I think this is stuck now. Okay, now here it is. So yeah, that's it for today's video. I hope you liked it, and do click on the like button, do subscribe, and share the video with your friends. Goodbye everyone.